we explain to you about comprehensive and detailed scientific explanation of the failure of SpaceX's Starship 9th test flight, breaking down what likely went wrong based on current knowledge of aerospace engineering and what is publicly known about the event. Overview of the 9th Starship test flight failure. On its 9th test flight, SpaceX's Starship successfully launched and continued for about 30 minutes before it lost control in space and ultimately disintegrated over the Indian Ocean. While no lives were lost, the mission is being called unsuccessful due to its inability to complete its intended objectives. Scientific and technical breakdown of the failure: loss of control in space. Key problem: the rocket lost attitude control while coasting in space, likely during the coasting phase before re-entry. Possible scientific reasons: reaction control system, RCS, malfunction. In space where there is no atmosphere, spacecraft rely on small thrusters called RCS jets to control orientation. If these thrusters failed or malfunctioned, the rocket would begin tumbling uncontrollably. Inertial measurement unit, IMU, or gyroscope failure. These instruments provide critical data on the rocket's orientation. A fault here could lead the onboard guidance system to make incorrect adjustments or fail to stabilize the rocket. Computer software glitch, or faulty navigation algorithms. Complex software controls the rocket's trajectory. A bug in the code could cause misfiring of thrusters or misinterpretation of sensor data. Premature re-entry and breakup. Over-the-ocean key problem: the vehicle re-entered Earth's atmosphere earlier than scheduled and broke apart over the Indian Ocean. Scientific explanation: incorrect re-entry. Angle: for a spacecraft to survive re-entry, it must enter at a precise angle. Too steep and it burns up due to intense friction. Too shallow and it skips off the atmosphere like a stone on water. Losing attitude control may have caused the rocket to hit the atmosphere at a wrong angle. Thermal protection system, EPS. Overload or failure. During re-entry, temperatures can reach over 1600° to 900°. If the heat shield was not oriented correctly or was damaged, the structural integrity of the vehicle would fail, leading to disintegration. Dynamic pressure and aerodynamic forces: re-entering the atmosphere while tumbling or at the wrong orientation increases aerodynamic stress. These forces can tear apart even strong materials, especially at hypersonic speeds, Mach 20+. Stage separation and vehicle design complexity. While earlier failures of Starship missions often occurred during the launch or separation phase, Flight 9 made it past staging and coasted for 30 minutes, suggesting that initial propulsion and separation systems worked. However, once in space, Starship is supposed to stabilize its orientation using onboard sensors and thrusters, begin controlled re-entry into Earth's atmosphere, use aerodynamic flaps to control descent, reignite engines for a controlled landing. Somewhere between orientation and descent, a system failure, whether mechanical, software-related, or environmental, disrupted this sequence. Why these failures matter. Scientifically, this failure highlights the complexity of orbital mechanics and re-entry physics, particularly guidance, navigation, and control, GNC, challenges thermodynamics of re-entry vehicles, real-time software reliability material, stress under hypersonic conditions, what SpaceX likely learned from the failure. Even though the mission didn't meet its goals, it still provided valuable data. How Starship performs in microgravity conditions over time. How well the heat shield and vehicle body hold up after 30+ minutes in orbit. What failure modes occur when control is lost at orbital velocity. Improvements needed in AI-based navigation, RCS design, and software fault tolerance. Not the end, but a learning step. Spaceflight is inherently experimental, especially with a system as massive and ambitious as Starship. Elon Musk's goal of colonizing Mars depends on learning from each test. While the 9th test failed, it pushed the boundaries further than earlier tests and exposed critical weaknesses that SpaceX can now work to fix. In aerospace, failure is data, and data is what leads to breakthroughs.